Chapter 7, Impulse and Momentum. Momentum is mass multiplied by velocity or force times time. Okay? Momentum does not have its own unit. You have to use the units that required to make it up. Like it says P equals mv. Or if you think about it, it's MVP. All right, easy way to remember. Okay, so P is momentum. If you have a car with a mass of 1,400 kilograms, maybe at 16 meters per second, you can calculate the momentum by just multiplying the mass times velocity. Notice the units are what makes it up. Okay, so you get 22,400. Impulse is change in momentum. Okay, if you were to push on something, if you were going to supply a force for a period of time, you're going to give that person an impulse. Okay, impulse is force times time, or it's mass times velocity. So you can set them equal to each other. Like you have Steve Stamkos here from the Lightning taking a slap shot, and the force that he applies to the puck is equal and opposite to the puck applying to the stick. All right, by Newton's third law. But the force supplied for the time equals the mass times the change in velocity. So if he applies the amount of force to that puck, all right, and he extends the time, all right, like in a slap shot, he's extending the time through the whole thing, increasing the time. The mass of the puck is not going to change, but the velocity will go up. So if you think of in hockey, if you have a slap shot or a wrist shot or a snap shot, they all go at different speeds. The slap shot goes the fastest because you're supplying the largest force for the longest period of time on the puck. Okay, same thing in golf, in tennis, lacrosse, everything. Okay, if you extend the amount of time, you're going to increase that overall speed. Now, if you flip it around, think about padding. All right, if you have like a shin pad on, and the puck comes and hits you, all right, the puck has a certain mass and it has a certain velocity as it comes and hits you. Okay, so all of a sudden, if the puck comes and hits your pad, it pushes the pad in towards your leg, all right, and because the padding is soft and squishy, right, and it has the hard outside, all right, it extends that amount of time. So your time here goes up, therefore the force felt goes down. All right, that's basically, and it spreads that force over a large area. Okay, so that's where all this comes into play. I think impulse and momentum are probably the most important thing when you talk about sports and when you talk about safety. All right, think of an airbag in a car. All right, the airbag saves your life because it comes out and extends that amount of contact time with the steering wheel. All right, instead of it going really, really fast, goes very, very slow, and it decreases that amount of force. So here's an example here. It says, if someone were to roll a bowling ball and a golf ball at the same speed, it would require more force or effort to stop the bowling ball compared to the golf ball. Now we know that the bowling ball has more mass, therefore it has more inertia, and momentum is inertia in motion, okay, versus a golf ball. However, if I took that golf ball and I hit it with my golf club at you, that amount of force might be equivalent to how much force you need to stop the bowling ball coming at you. Okay, so instead of having a small velocity, large force or large mass, all right, if you have a small mass, you could increase the velocity, and it would still be the same amount of force felt. Okay. All right, so it says Steve Stamkos applies 250 newtons of force to a 0.8 kilogram puck for 0.17 seconds. How fast does the puck travel in meters per second and in miles per hour? So here's your force, here's your time, here's your mass. You can calculate the velocity. The velocity comes out to 53.13 meters per second. And the conversion here is 2.2369, all right, times the 53.13 will give you 118.83 miles per hour. All right. Conservation of momentum. The total momentum of a system before collision is equal to the total momentum of the system after the collision. Unless there's a change in mass of one or more objects during a collision, the only factor that would change is the velocity. That velocity, remember velocity is speed with direction. So even if it's just the direction that changes, that might be enough. It says recall the velocity includes speed and direction of an object. So during some collisions, if there's no change in speed, there must be a change in direction of the object or objects. An example of this is like when two opposing soccer players bump into each other while racing for the ball. They basically bounce off of each other and keep going. All right, collisions. There are three basic collisions we're going to talk about: elastic, inelastic, and recoil. Elastic, all masses stay separate and they bounce. So if you're thinking about billiards or playing pool, that's an example of an elastic collision. An inelastic collision would be someone tackling another person, or two freight cars when they hit a couples joining together. Okay, and then recoil is when two things are sitting there, like usually maybe like under stress, and then all of a sudden they're released, and they go. One goes one direction, one goes the other. The momentum of this one going this way, and the momentum of this one going this way, all right, are equal and opposite. So here's an example of an elastic. Now, this is what I call the elastic formula. All right, M1v1 plus M2v2 initial. So this is momentum of one boy plus momentum of another boy before they collide, equals the momentum of the one boy plus the momentum of the other boy after they collide. Now, in elastic, remember, they're staying separate, so they're bouncing off each other. They're not tackling each other. All right, put your numbers in. Now, if one's running north and one's running south, we would have to say north is positive, south is negative. So if you look over here, 7 here is negative, right? It's south, okay? And then you have 1.65 continues on after the collision, so that's positive. We want to know what happened to the 72 kilogram boy, and the 72 kilogram boy gets knocked backwards at 2.7. His backward is north, though. It's positive. So you put your numbers in, make sure you do the math correctly, multiply each of these things first, then put them together, so you can see that they subtract. Then over here, you're going to subtract this 138.6 over, not dividing, okay? You divide the 72 over to get to it. All right, inelastic. This is where they're tackling each other, okay? You have the momentum of the first person plus the momentum of the second person equals the combined masses with one velocity. Right? If you notice, the 40 is moving at south, so he's -7. This one's moving north, so he's positive. All right. We usually say north and east are positives, south and west are negatives. Okay, just for your information. So here they calculate out, and the final velocity of the two of them is -0.1. So that means when they get tackled, they move south at 0.1 meters per second. Recoil. A 7 kilogram shotgun shoots a .028 kilogram slug at 450 meters per second. How fast is the recoil of the gun? So you have M1v1 plus M2v2 equals 0. All right. 7 times v plus 0.028 times 450, all right? And you end up, you subtract this over, and then you divide, and you get -1.8, and it's backwards. So if you think about a recoil is backwards. Now, how could you change the recoil and make it less? Well, one of the ways is by increasing the mass. All right, if your gun was heavier, it would have less recoil, okay? Because the momentum of each section is conserved. All right, so if you increase the mass, then the velocity will actually kick less. Okay, so a heavier gun shooting the same caliber weapon, bullet, would actually have less kick than a lighter gun. Collisions at angles. Do each formula twice, one for X component, one for Y component, and then use the Pythagorean theorem and trig for the angle. So this is like when we did vectors in the beginning of the year. You're going to do the same type of thing, okay? All right, so we've got a question here. It says an 80 kilogram car moving at 14 meters per second east gets hit by a 15 kilogram car moving at 8 meters per second north. Okay, so this is like this. This one's going east, this one's going north. They hit and they go together. Okay. Let me just see. Nope. Okay. All right. So if we're going to do this, basically you want to do, it's an inelastic collision. So you're going to do M1 V1 plus M2 V2 equals M1 plus M2 V2. Right? You do this in terms of X and then do it in terms of Y. You get two numbers. So for the first part, east, you have 800 times 14 plus 0 because the car moving north is not going east. All right? Equals 800 plus 1500 times V. And then you solve for V. And this will be your Vx. Your Y, same thing. M1 V1 plus M2 V2 equals M1 plus M2 V1. This is 0 because it's going east, it's not going north. And then this one is 1500 and moving at second equals 100 plus 1500 Vy. So you solve for Vy here, and now you have your Vy, you have your Vx. You do the Pythagorean theorem. If you want the angle, you do inverse tangent of y over x. Okay? This one here is an 8 kilogram bowling ball moving east, stationary pin. After the collision, the pin flies off at 25 meters per second with an angle of 30 degrees north of east. What's the velocity of the ball? Now, this is an elastic one. So M1V1 plus M2V2 equals M1V1 plus M2V2. You do the same thing. You do it all in terms of X, you do it all in terms of Y. Okay? And that's how you're going to do that. All right, some images. All right, so here is a picture of a runway truck catcher used in the western part of the United States coming out of the mountains. All right, you have bungee cords and then like a mesh type catch here. And what happens is as the truck comes out, it hits it, stretches, and it keeps producing impulses over and over and over again to slow it down so that the driver is safe. Same thing here. This is a runaway catch for planes when the landing gear is not working right, or if the hook doesn't come out. You just basically put this big net up on bungee cords, and when the plane goes through it, it stops them. All right.